So hi, my name is Hermann Kroll, and this is my presentation, Open Information Extraction in Digital Libraries, Current Challenges and Open Research Questions. This is a joint work with Judy Alchar and Wolf Thilo Balke. So let me start with a short introduction to the topic. So the main objective of information extraction is to transform unstructured into so-called structured information. So one example might be the extraction of statements, structured statements, from natural language text. So for example, take some document, perform an information extraction, and having a triplet in the end. This might be a typical process in information extraction. And typically, you can do information extraction in two ways. On the one side, you can perform supervised methods, so for example, relation extraction, which require training data to train extraction models, and then you can precisely extract one relation. And on the other side, you can perform unsupervised methods like open information extraction that have some advantages. And let us have a closer look on these methods. So the main goal of open information extraction is to extract statements without knowing entities and relations a priori. So you train one extraction system or you build one extraction system, and then the system can be transferred to arbitrary domains, for example, and be used to extract structured information from natural language texts. And in this sense, we understand open information extraction as an unsupervised extraction method. And you can build these systems in many ways. So you may choose a rule-based architecture or some modern neural architecture to achieve the best performance. So the promise of open information extraction is that it works without knowing the relations a priori, and you can just apply it in a domain. This sounds really great, but let us have a closer look on the practical aspects. So if you perform open information extraction, you will typically raise three major research questions here. So the first aspect is that OpenIE systems are usually precision-oriented. So you try to extract a statement if the system is really sure. And in this sense, it might not be able to extract statements from very complex sentences, for example, or if the relation is hidden in a large phrase. So if you do not have the information available as a subject, predicate, object in the sentence, maybe hidden in some clause, then OpenIE systems may fail to extract the statements correctly here. The next aspect is that open information extraction are typically not canonicalized. That means, on the one hand, the noun phrases, so subject and objects, which are extracted, multiple noun phrases might refer to the same concept. So, for example, we might extract NY, New York, New York City, and all refer to the city, New York City, but this is not an information which open information will deliver you. And so you might canonicalize these noun phrases later if you want to have synonyms linked to the same concept. The same holds for verb phrases too. So you might have different verb phrases like has birthplace or is born in, and they all describe the same relation, but the relation is extracted in via different verbs. And if you want to use these extractions in a later downstream application, then it might be helpful to canonicalize the noun phrases as well as the verb phrases to also cover synonyms, for example. So if someone is searching for NY, then the system should in addition deliver New York and New York City and so on. And the third aspect of open information extraction is that it might extract complex arguments. And a complex argument involves multiple concepts. So let me give you an example. So the phrase below, Einstein won the Nobel Prize in 1921, has a complex object. because on the one hand, we have the information about the Nobel Prize and a year information. So if we think about knowledge graphs, this is not something which you would expect as an object. This is some more complex concept. So there's the concept Nobel Prize and a date concept. So, and you must handle these complex arguments if you work with open information extraction in practice. Otherwise, you may have some kind of unhelpful extractions in the end. For this short paper, we analyzed two open information systems in two domains. So we have a closer look on a more reliable and older tool, the Stanford CoreNLP suite, which has an open information extraction component, and the latest development, OpenIE6, which is built upon a neural architecture. We selected 10 news articles from the New York Times and 17 biomedical articles from PubMed to generalize our findings in some way. And we asked the following questions for our evaluation. So first, how precise will open information systems keep the original information of the sentence? And therefore, we choose to classify the sentences in three categories: fully retained, partially retained, or not retained. The next question is, how does open information extraction react to different kinds of sentences? So we choose to select simple sentences, compound sentences, complex sentences, nested sentences, and negated sentences. So we always add more complexity to the sentences and have a look at the extraction and try to understand if this in fact affect OpenIE and in which way. So how will the performance be decreased, for example? The last question is, how complex will OpenIE arguments be in practice? So we count how many extracted noun phrases, arguments are complex and how many are simple. So let us jump directly into the evaluation. And I first want to show you some observations and some examples. So, for example, if we have a compound sentences, so the first sentence is India has about 10 million coronavirus cases now, and schools have been offering online instructions since March. So both tools are capable of extracting the first part of the sentence. So India has about 10 million coronavirus cases now, but CoreNLP, for example, ignores the second part of the sentence completely, and only OpenIE6 is capable of extracting this information. If we have a look at a more complex sentence, so for example, a sentence with that information, so relentless advertising campaigns are telling Indian parents that coding is critical because making children code will develop their cognitive skills. So in this case, OpenIE6 is capable of retaining the information, but at a high price. So the subject is some kind of relentless advertising campaigns, are telling as the verb, it seems okay, but the object is long and covers a whole sentence fragment. So Indian parents that coding is critical because making children code will develop their cognitive skills. And OpenIE6 extracts this sentence fragment as an argument, as a noun phrase. So if you try to bring more structure in your collection and you perform OpenIE, and then you end up with arguments which are so long and so complex and would need more processing, then this might not be helpful at all, right? Because parsing this whole argument into single concepts is currently not processable by OpenIE tools. They will leave you with this fragment and then it's your job to handle it. More observations are we tested nested sentences. So for example, first sentence, as a result, many marine species are impeccably adapted to detect and communicate with sound. And both tools cover the first part of the sentence, but only OpenAI 6 is capable of also retaining the second part, so detecting that many species are adapted to communicate with sound, and the second extraction to detect with sound. So OpenAI 6 can do it for you, but older tools might fail here because the nested clause, the second information, is ignored at all, and this might be a problem. And the last part I want you to show here are negated sentences. So for example, recent studies show that men will not always be the hunter. And in this case, kernel P results in an maybe not helpful extraction at all. So recent studies show man. So here the main part of the sentence is completely missing. And OpenAI 6 extracts two statements. So recent studies show, and then the whole sentence fragment. So that man was not always a hunter. And another extraction, man was not always a hunter. And in both extractions, you see some problems. Yeah. So in the first extraction, you have a very long object, so a whole sentence fragment, which you have to process later. And in the second case, the information about the recent studies is completely ignored. So there you might end up with some factual information, and the context that this has appeared in a recent study is completely missed. So this is also a problem when working with open information extraction here. And we have quantified our results. So we asked 3 raters to rate the extraction or to classify the extraction into 3 categories: fully retained, partially retained, or not retained. So if the extraction covers the main information of the sentence. And the question which is directly connected to it is how does OpenAI react to different kinds of sentences? And we describe this table in detail in our paper. So if you want to have a closer look what works and where are problems, you might read our paper. And just to give you a short feeling about what works. So if you have very simple sentences, so small sentences, then modern tools like OpenAI 6 are capable of extracting the information in every situation. If you are getting more complex sentences, so compound or complex sentences, then the precision will decrease and some aspects of the sentences, some important information may not be considered in the extraction. So this could be a problem. And negation and nested sentences can already be handled very well by modern tools, but if we switch back to the older core NLP suite, then you see the precision is decreased. So complex sentences or the information of complex sentences is not covered fully in many cases, and nested sentences and negation, there's always the important thing which is missed in core NLP extractions. So this is a common trade-off. If you choose a more precise and more based on neural architecture, so more modern tool, then you will need more runtime and more CPU and GPU time, but the results will be more precise. On the other side, core NLP is much faster and much reliable, so it can extract the statements in only in a few minutes, while OpenAI 6 needs 1 hour, for example. So there might be trade-offs to choose here. The second part of our evaluation was the question of how complex will OpenAI arguments be in practice. So we count how many arguments are complex and how many are simple. So a simple argument is just an argument which only covers one concept. So a city, a location, a price, and so on. A complex argument is an argument which involves multiple concepts. So a price and a city, a price and a date, a person and a date, and so on. And in this case, you see that CoreNLP extracts single or simple concepts arguments in most of the cases, while OpenAI 6 tends to extract much more complex objects if and this could be a problem in practice because smaller arguments are much more easier to handle in a downstream application, while complex arguments need more filtering. We also have published a toolbox for the nearly unsupervised construction of digital library knowledge graphs at this year's JCDL. So this is available as open source, written in Python, published with a free license. And the main idea was, if we have natural language texts, how can we use open information extraction techniques to produce a precise knowledge graphs? So what does already work very well, and so we asked these kind of questions and tried to answer them in this paper. So if you're interested in more information, how you can use open information extraction to actually build something like a knowledge graph, so end up with precise relation and precise concepts, then you might have a closer look at our JCDL paper. And for this talk, let me come to a conclusion. So the conclusion is based on two things: on the evaluation in this paper and on our findings of the JCDL paper. I strongly believe that OpenAI helps to bring more structure into otherwise unstructured collections. Supervised methods would always achieve a higher quality, but they require cost-intensive training data. So you must extract or you must collect many examples for a single relation, and then you have an extraction model which only works for this one relation, and this could be a problem in practice. So we formulate 3 research questions here to move on from this paper. The first one is trade-off accuracy versus runtime. So if you want to achieve the best precision, then you have to use the latest neural extraction architectures, and they will need powerful GPUs, for example. In addition, complex arguments might lead to apply additional filtering and cleaning, and this will take even more time. And the question here is, the second question is, how can we handle them? So what should we do to handle complex arguments? Can we somewhat separate them further, and so on? And the third question is, how can OpenAI outputs be canonicalized? So how can we identify which noun phrases and verb phrases describe the same concepts and relations, and how can we automatically canonicalize them for a downstream application? So thank you for your attention. If you have any questions, you can contact me via mail or on Twitter. Thank you.